Hi, this is the notes for lesson 2.2. We're analyzing conditional statements. You should have already filled in your frame, so you know what we mean by conditional statements. So here's our first example. If two angles form a linear pair, then they are supplementary. So it's conditional because it has if and then. We need to figure out our hypothesis and our conclusion. So this part right here, that's our A, that's our hypothesis. So two angles form a linear pair. That's our hypothesis. And then our conclusion is this part right here. That's our B, our conclusion. They are supplementary. So this is just intended to make sure you can pick out what's the hypothesis, what's the conclusion. Hypothesis comes after the if, the conclusion comes after the then. The next example here says, rewrite the conditional statement in if-then form. So it says, all birds have feathers. So we're going to say, if something, then something else. So the first part, it's birds, and then feathers. So we can say, if an animal is a bird, then it will have feathers. So I've now changed just a regular statement into a conditional statement, an if-then statement. So let's look at the next one right here. It says rewrite the statements as a biconditional. So biconditional tells me I want if and only if in there. If Mary's in theater class, she will be in the fall play. You could say then she will be in the fall play. If Mary's in the fall play, then she must be taking theater class. So we got two pieces. First of all, Mary is in theater class. So we're going to write first, Mary is in theater class. And then we're going to write our if and only if. And you can just write IFF, if and only if. Our second part will be she'll be in the fall play. So Mary is in theater class if and only if she is in the fall play. So I've taken a statement, really two statements, the if and then were switched around in both of them, and just changed it into a biconditional by putting if and only if in the very middle of it. So let's practice writing our conditional, converse, inverse, and contrapositive. And now we're also going to look to see if they're true. So it says, write if-then form, the converse, the inverse, and the contrapositive of the conditional statements. Decide whether each statement is true or false. If false, give a counterexample. So guitar players are musicians. So here's my A part, guitar players. And here's my B part, are musicians. So conditional is if A, then B. That's what a conditional is. A converse, remember, is if B, then A. The inverse is if not A, then not B. And the contrapositive is if not B, then not A. Okay, so I've defined all those things. Let's now make our statements. So the conditional would be if you are a guitar player, or you could say if someone is a guitar player, then you are a musician. Well, if you play the guitar, you're definitely a musician, so that's true. The converse is if you are a musician, then you are a guitar player. Well, let's think. Is anybody a musician who's not a guitar player? I play the piano. I can't play the guitar. I would consider myself a musician because I play the piano. So this is definitely a false thing. And our counter example is you can play another instrument. Or couldn't you sing and you'd be a musician? You don't have to play the guitar, just be a musician. The inverse is if not A, then not B. So if you do not play the guitar, then you are not a musician. Well, that's almost the same as the last one. Definitely false because, again, you could play another instrument or you could sing. Okay, so it's definitely a false one as well. Our contrapositive, if not B, so if you are not a musician, if you're not a musician, then you are not a guitar player. Well, that's true. If you're not a musician, you can't possibly be a guitar player. So that's true. And again, that contrapositive is kind of like the conditional. Let's keep going here. All right, let's look at this next problem right here. And the next problem says, write the converse, inverse, contrapositive of the conditional statement. Tell whether each statement is true or false. If false, give a counterexample. So the same thing. So our first, if a dog is a Great Dane, then it is large. Now we're talking about dogs here, not puppies, so this is definitely true. A dog is a Great Dane, this is our A. It is large is our B. So our converse says, if B, then A. So we'll say, if a dog is large, then it is a Great Dane. Well, there are definitely other dogs that are large that are not Great Danes, so this is false. I think Dalmatians are very large dogs. Maybe I'm not thinking of Dalmatian. There's some very large dogs that aren't Great Danes, and probably some of you know them better than I do. I don't know dogs real great, but I know this is not true. My dog is little. The inverse tells us if not A, then not B. So we're going to say if a dog is not a Great Dane, then it is not large. Again, that's almost the same as the last one. That's false. Our contrapositive here is if not B, then not A. So we're going to say if a dog is not large, then it is not a Great Dane. Well, that's true, because it's not big, it's not going to be a Great Dane. All right, let's do the last problem here. Number 6 says, if a polygon is equilateral, then the polygon is regular. So let's first pick out our if part of it, or our A part. So right here, a polygon is equilateral. That's my A. Okay, so that's my hypothesis. The polygon is regular is my B, my conclusion. So if a polygon is equilateral, then the polygon is regular. Well, that's false. Just because it has the same number of sides doesn't mean it's regular. What about a star? We could have a star, and if I were able to draw this perfectly, a star could have all of these side lengths exactly the same length. And it still wouldn't be regular because all the angles would be different. So my converse is if B, then A. So we're going to say if a polygon is regular, then the polygon is equilateral. And if we think about it, that's true, because in order to be regular, it has to be both equilateral and equiangular. So that's definitely true. The inverse is if not A, then not B. So this is if a polygon is not equilateral, then the polygon is not regular. And that's pretty much like the one, the converse. It's also going to be true, because if it's not equilateral, it can't be regular. Our contrapositive, this is the if not B, then not A. So our contrapositive would be if a polygon is not regular, then the polygon is not equilateral. So this is really just like the first one as well, and that's going to be false, because just because it's not a regular polygon doesn't mean it can't be an equilateral polygon. So this is the end of the notes for lesson 2.2. Make sure you've watched the frame as well, and have a great night.